Hello, my name is Muhammad Khairul Ashar bin Ismail and I'm so excited to be here. My paper ID is 51 and paper title is Fabrication of Parallel Ankle Rehabilitation Robot. Before I get started, I want to apologize because right now I'm not in formal way to make a presentation in front of the panel due to the problem that I cannot be avoided. So before I not waste the time, I want to tell you about what is exactly fabrication of parallel ankle rehabilitation robot. I'm sure when people heard about rehabilitation and the thing is come out in their mind is to cure our body from the injury to get a better. It is not only for a parallel ankle injury but also can be used for the person who got a stroke to make a therapy using this. Nowadays, there's a lot kind of this rehabilitation robot, especially at hospital or physiotherapy units, clinics, and health center. The model that are existing are very expensive cost to use and heavy model. For the project scope, I'm more focused on two types, which is software and hardware. For the software, I use SolidWorks for the design of the model with dimension. And the hardware, the material structure of the model are an aluminium. And then adjustable for height of foot platform. For the review of the ankle and our leg have three rotating of axis which are S axis, Y axis, Z axis. Each of axis have two motion axis. There's a name of the motion and this angle of the rotating of motion. Based on the database human ankle characteristic, the combination database and from ankle motion and then apply to the mechanical parts. For the methodology, in this methodology have three stage, which is first stage design the prototype. Okay, after the research about the project, it's going to be design the robot by using software. I've mentioned I use SolidWorks, and then for the second stage is construct the hardware. Then after the being design the robot using SolidWorks, then I being construct the hardware parts. And the third stage is assemble software and hardware. This part, and then be testing, analyze, and so for the analyze ankle joint structure. Before I go to build the platform, I have to analyze foot, which is in my previous slide I have mentioned that each of the axis have two motion which with a different angle. Then after that I made a platform and then combination between a ball joint with a foot platform is important because the ball joint can make a motion for the foot platform as same with the rotating of ankle motion. Okay, this is our foot and this each axis, and then I apply to the foot platform, and then if you can see this thread, and then this ball joint. Okay, for the first stage, design the model. I design the framework design. This framework design with center here. Okay, then the foot platform. This foot platform. Yeah. And then this ball bearing and the thread. This is a thread, and this is housing with ball bearing. Then I'll show you. Okay, this is a combination ball bearing and full platform. This is a full platform. The previous slide I show you, and then this is a thread with a ball bearing. And then after that, a full complete design the model. Then this is a full complete the framework, the full platform, the ball bearing, and the thread. And then for the second stage, hardware construct. For the Phase 1, measure the dimension at the aluminum using a measuring tape and so on. And then for the phase 2, cutting the part that have been marked and measured using a measuring tape. And then for the phase 3, make a hole on the part has been marked. And then phase 4, combination part by part. This is use a rivet, elbow ruler, and so on to make a combination, full complete combination between a ball joint, thread, and full platform. Okay. This is a construct of the framework. Yeah, I put a L joint here, bracket L, to support the framework, to prevent it bend. And then this center here. And then for the process setup, in this process setup contains 4 process: operation process, mechanical setup, wiring setup, and model setup. Okay, we're going to the operation setup. In this operation setup, has 2 sections, which is hardware and software. For the hardware section, it contains 2 operations also, which is mechanical setup, wiring setup, and also for the software I use SolidWorks and Arduino. Okay, this is mechanical parts. In this section, the construction of the model has been done by using a software SolidWorks for modeling. After the modeling has been done, the construction hardware was carried out with the selected material. For this model, the material for an aluminum which had been chosen because this material is lightweight, stainless steel, and long-lasting material than the others that had been discussed. So for the wiring setup, okay, this for the wiring setup has been implemented after the finish for the mechanical section. In this wiring section, the circuit as for the electrical component must be completed because to collect the data. If you can see this form stepper motor, I put up the framework with a string tied each point of the platform, and then 2 breadboard, 1 Arduino Omega, and 1 DC converter. And then this I use a power supply to run it. Then so for model testing, after overall section has been completely installation, the movement 2 degrees of freedom for the platform which no load have been measured. The result must have 2 degree of freedom movement, which is 2 position X axis and 2 position in Y axis. The platform for the foot has been made bigger size due to the variety of people size foot to use this model, and should have a drawing size of foot easier to the user to put on the platform. This platform can make the user more comfortable and prevent injury while using the model. So if you can see this image in 0 degrees of horizontal, and then today I going to the right side, okay, then we going to the left side, and then you're going to the up, and then going to down. Okay, we go to the next slide. Okay, for the result and analysis, mechanical of prototype. After design in the SolidWorks software, the construct of the model has been done. It can use the selected material, which and aluminium. Then direction of rotating stepper motor. Okay, this is a table show you two axes, which is X axis and Y axis. Each of axis have two name, two motion. Okay, and then this motor 1, motor 2, motor 3, and motor 4. So this motor make a forward and backward to make a rotation or a motion for the full platform. And then okay, this is a result analysis for the full platform based on the motor that running forward and backward. So this is 0 degrees horizontal, and then going to the right side, and then it going back to the 0 degrees horizontal, and then it's going to the left side, and then it back to the 0 degrees horizontal and going to up side, and then it going back to the 0 degrees horizontal, it going back to the downside, and then it's going to 0 degrees horizontal, and it's a continuous loop. You can continuous until you stop the battery. So this is a result analysis with angle with load and no load. Then okay, this is, you can see this for the table. First, analysis model with no loads. Okay, this is axis to axis motion. This predict angle and actual angle. Okay, for the analysis model with a load, I put my leg on the full platform, and then I use a phone with application to see the angle of the motion. Okay, then this is a different angle, actual angle in the no load and with a load. And then for the conclusion, in a nutshell, the ankle rehabilitation robot is a successful build. With the successful design on SolidWorks, the dimension for part by parts are based on the design in SolidWorks to combine and make the model. The ultimate intention of the proposed ankle rehabilitation robot to assist the disabled individual who suffer from lower body motor impairment by giving support to their lower body, especially the ankle. The mechanical design of the ankle rehabilitation robot is based on the real concept of the human ankle. The experiment result presented the ball joint under the full platform and adjustable height for the full platform. The result didn't fulfill the expectation, as the platform didn't reach the maximum required movement of the ankle. Therefore, there is a need for motor that can support the load from the patient. Additionally, the lack of closed loop mechanism in this project had deterred the platform from reaching the ideal position. Thus, introduction of closed loop mechanism must be introduced in order to improve the performance of the robot significantly. So, okay, this is end of my slide. I want to thank for the panel, and very apologize because right now I'm not in formal way. And thanks for your time. Have a good day. Thank you.